Okay, welcome back. Last time we were talking about inserting the wire. Now the wire was 2.5mm 2-core and earth 7067 double insulated cable. Now what I would like you to try and do, if it's available, rather than necessarily getting the cable from the rack over below the safety vests, I'd like you to go to the metal recycle bin and see if there's a bit of cable long enough there. It really only has to be around about 650mm long. Now I've got a prepared bit, so I'll get that. Now what we do, we insert that into the duct, like so, pushing your tail up through like that and just putting about 6 inches through, 150mm through, and bending it over. Now when we lay the cable in the duct, we want to make sure it lays flat, so we run our thumb over it, hold the top, run your thumb over it and push down into the duct like that, so it actually hugs the back of the duct. And it should sit relatively flat like so. And then it's just a matter of case of putting your cover on. Put your cover on, start at the top, give it a little tap in, line it up, give it a little tap on the way down, work your way down, keep giving it a little tap. Just run your thumb over it like that just to make sure it's sitting nice and flat. And basically now, you're ready to terminate the power point in preparation for your testing. Now to do this, you need your standard toolkit. So I'll go over onto the rack here and get a standard toolkit, just like you would do. I'd like you to get into the habit of using these tool belts and actually putting them on. Now if you need to put them on and size them to yourself, take the tools out if it's easy for you to do so. Put the tool belt on. I personally like the tools to be sitting around about on my hip like so. Some people have them around the front like that, but that's okay. Just got to be careful that when you bend down you don't stick the screwdriver into your leg or something. That's why onto the side of you it tends to be free to give your body a full movement rather than necessarily causing adverse issues. Now, stripping the cable, there's a few little secrets in actually doing this, so leave yourself, just pull a bit extra up, leave yourself about 100mm back, and what I generally do is I crease the outside insulation of the cable enough to put a dent in the cable like so, but not enough to penetrate the insulation below. Then basically put the pliers on one conductor and push the other conductors away from it, and I work my way down to that creased section of the outer insulation. I peel the conductors, and if I've creased it correctly, I should be able to pull that straight forward like that, and that'll just break off. Same with the smaller section, pull off, and away we go. Just lay the cables against the wall so you're not tripping on it. Now to strip the internal conductors, the black is the neutral, the red is the active, and the green and yellow, which is 70% yellow or green and 30% of the other colour. In this case it's 70% yellow and 30% green. That's the earthing conductor. Now to strip this, there's many methods. I'll show you one. This is what I do. I come back around about 30mm from the edge and I just lightly crease the conductor, releasing the jaws 2 or 3 times without doing other insulation, and then I hold the conductor in my hand like that. My fingers pull in one direction and my thumb pushes away in the other, but I haven't compressed my pliers too tight. If my pliers are compressed too tight with the jaws too close together, what will actually happen is you'll actually crease the conductor and you'll crimp the conductor. When you go to push, it won't push because it's actually biting into the conductor. And potentially when you start to twist the conductor up, which you'll do in a minute, you'll more than likely break off one of the cores, which is a 7-core conductor. So don't do that. You're better off to go nice and gentle and do too little to start with rather than too much. Over a period of time, you'll get to realise, with practice and repetitive use, just how much you do have to do to be able to get it to push off every single time. Once you've done that, now I want you to prepare the conductors for termination of the power point. Now in doing so, twisting the wires together, you've got to pull forward at the same time and twisting, like so. So a twist and pull, a twist and pull, a twist and pull. Keep doing that, working your way through so that the actual, as the wire twists up, it forms a lovely little pattern. And just nip the bit at the end, twist it again, and get a nice little plaited conductor like so. Do that to all three. Because there's only one wire, we're going to double the wire over so that the wire is twice the width as it normally would be. So there's more for the screw of the power point to make a connection to, which makes a better connection, a greater ability for the actual current to be able to deliver via the conductor to the end appliance that's going to be plugged into that power point. We're not going to be plugging something in, but you're preparing it so it can be plugged in. Now just to double it over, we don't want to double the conductor so that the copper goes past the insulation. So you look at it by eye, I generally say the width of the jaws, we bend it over and we crimp it like so, and we get a nice neat connection like that, so the duct is just sitting flush with the edge of the insulation. Always pays to strip more copper off than you need to start, more insulation off the copper to start with, which you can always cut some more off, but it's very, very hard once you've twisted it up to pull more insulation off. Because as you twist it up, you can increase the surface area of the conductor from when it's previously been not twisted together. So that's my three conductors ready to go into my power point. Okay, I've got my power point. Make sure all the screws in the power point are released and undone. I need a bigger Phillips head screwdriver. Excuse me, I'll just get that. Got my correct Phillips head screwdriver now. Now, good practice is to always put the earth conductor in first. And it doesn't matter which of the other two you put in next, as long as all can go in there. Now what you don't want to do is make sure that when you put the conductor in, that you don't push it in too far, so that when the screw screws up, it doesn't screw on the insulation, it screws on the conductor behind it. So don't push it in too far so it goes behind the screw of the insulation. Just screw it in far enough so it actually, the screw screws onto both surfaces of the bent over conductor. But the outer insulation, the single insulation, the red, black and the green and yellow, wants to enter the tunnel at the beginning and only the beginning. It doesn't want to go far inside. Otherwise you will find that you will be screwing up against the insulation. And that's the last thing you want when you do a test. You won't get any circuit between your continuity test between the one end of the conductor and the other, because it's insulated by the outer insulation of the conductor and you haven't got the screw on the conductor itself. Now some of these screws have been used a lot. You might have to double check the tightness of the screws. It's not muscle, it's just a case of getting it nice and firm. And we should see something like that. That's ready to screw back to the power point. I'll just pull a little bit back because we don't need that much in there. We'll just bend it over like that. At the other end, as we've practiced the first point, we can do the second point now. So I'll just go down slightly. Just review the camera so you can see what I'm doing. Okay, so now we're at the bottom end. Same thing again as we did with the power point. We'll crease the outer conductor again, give it a crimp. If you want to turn it over so you can crimp both sides, do so. Same level of pressure. Grab the conductor, pull it back to the crimped part of the outer insulation in both cases, and you should be able to just pull them off with no mark on the internal insulation. Now I'm not going to criticise how you do this. You can actually use the pliers. We do have another tool in the workshop which I'll just go and get and I'll just show you that. This other tool we have in the workshop is the cable strippers. These cable strippers have got the labels on one side which tell you the size conductor to put under what lined up holes. And there's the holes there as we see if you go in there. Now in this particular case, you're better off to go to a bigger hole than a smaller hole because you don't want to cut the copper. So even though it's 2.5mm cable, it says here that the 2.5mm cable is the second hole from the right. But because the outer insulation is on top of it, quite often that the 4mm cable, which is the far right hand hole, looking at it as you're seeing it now, it'll still crimp the insulation enough that when you press the straw together and pull away, the insulation will still break and pull away from the cable. Let's just prove that. So once again, we go in about 30mm, we put it in, go into the 4mm one and push it away, and there we are. See, we haven't actually used the actual 2.5, we've used the 4mm hole, and it still works effectively enough because it's grabbing enough insulation with enough force to be able to pull it away from the internal conductor. And we know because it's a 4mm hole, there is no way in the world it's going to actually crimp the internal conductors, and that's the desired effect. We do not want to crimp the internal conductors because that's part of a termination point, and therefore the more conductors that haven't been compromised, the better the connection, and ideally we want all conductors to be there all the time, doing exactly what they're designed to do, and that is to carry electricity to the load from the source. Okay, I've got a bit of mess on the floor there now, so what I'm going to do, I'm just going to make sure that I've cleaned my work area ready for the next scenario. So there's no harm in being clean in the workplace. So I'll get the broom. Now I'm going to create more mess, so I'm not going to sweep it right up. I'm just going to sweep it in a little pile away from where I'm actually working, so that there's no way that I'm going to be compromised in any way, slip, trip or fall, making it a safe work area all the time, not only for me, but for the other people who are also working in the same work area, because there'll be more than one student working in these tables at the same time. So my duty of care in the workplace is not only to myself, but to my fellow people around me. So I've got to make sure that I do everything I possibly can at the time that I'm working to keep the workplace safe. So we all have a responsibility there. Okay, I now got those cables ready to twist up. So I'll do the same thing I did with the power point. I'll twist them up. And I will double them over again because I wanted, as part of the assessment, you will actually be asked to do this, and your competency in doing this will be assessed. So therefore, as this may be the first or second time that you've done this, don't beat yourself up if you can't do it first time around. Leave yourself a bit of spare on the bottom end of the cable, so if you have to do it again because it's not good enough first time around, because the assessor says, please do that again, I'm not happy with that. Because you'll have to show the assessor to be assessed, obviously, the teacher to be assessed, that they're not going to be overly critical if you have to do it several times. In fact, in most cases, you will have to do it several times to learn and to get good at what you're doing. Repetitively trying the same task over and over, and the more you do it, the more competent you will be. But in the assessment of this particular unit of competency, fix and secure, we have to be comfortable, and you have to be competent enough to be able to complete the assessment within the guidelines of the assessment criteria. Okay, so I've now got the PowerPoint there, I've now got the bottom end done. Now I'm ready for myself to actually screw the PowerPoint back. I can do that by getting 2 screws out of the Milwaukee screw box at the back of the unit, the back of the store here, the workshop area, so let's get that. And that's from the Milwaukee screw case, adjacent to the pedestal drill, the back left hand pouch or container in the Milwaukee screw box. Now when you screw this back, it's important to just make sure the cables, when they go back, that they're not going to get compromised or stressed in their joint. Just put a nice little bend in them so when they can go back and fall back into the opening of the mounting block without any undue rest upon the joints that you've already made to the screws in the back of the power point. Get one screw started, don't screw at home. So the power point's lined up, get the other screw and you can put it in the hole. And now it'll line up because it's nice and easy to line up. Find the other screw that you put in first. This is not muscle again, it's method. Just do them so that they are two. Holding the power point firmly enough, but accurately enough and firm enough to hold your position. And there we are, we have the power point mounted. Now we're ready for our testing. I'll press pause, ready for our testing.